3'-deoxyadenosine, 3'-DA or cordycepin, is a nucleoside analog drug-like natural product that has anti-tumor activity by regulating several signaling pathways associated with tumor growth and metastasis. The mechanism of action of this drug is 3'-deoxyadenosine triphosphate, 3'-DATP, provokes termination of RNA elongation and inhibits polyadenylate polymerase, PAP. It also interrupts EGFR signal transduction. 3'-DAMP inhibits the activity of phosphoribosal pyrophosphate aminotransferase and activates AMPK. 3'-DA mediates apoptotic signaling via adenosine ADORAS and death receptors to inhibit lung cancer cell proliferation and induce apoptosis. All of these activities lead to apoptosis and inhibition of cell proliferation. 3'-DA is thought to enter cells via the human equilibrative nucleoside transporters HENT1 and to be phosphorylated by adenosine kinase AK to 3'-deoxy monophosphate 3'-DAMP. 3'-DAMP is phosphorylated twice to the active metabolite, 3'-deoxyadenosine triphosphate, by the combined actions of adenosine monophosphate kinase AMPK and nucleoside diphosphate kinases NDPK. 3'-DA is also subjected to metabolism by adenosine deaminase ADA, which rapidly metabolizes it to the inactive 3'-deoxyadenosine. Despite the potent anti-cancer activity observed in vitro studies, cordycepin has not been successfully developed or approved as a chemotherapeutic agent. 3'-DA efficacy is severely limited by its rapid metabolism into an inactive metabolite by ADA, downregulation of HENT1 transporter, and lack of expression of kinase enzymes. In response to some of these limitations, 3'-DA entered clinical trials in combination with the ADA inhibitor pentostatin. Exploiting phosphoramidate chemistry, nucleoside analogues have been converted into activated nucleotide analogues with the addition at the 5' position of a phosphate group, protected by specific combinations of aryl and amino acid ester moieties. In case of cordycepin, protide form can bypass the premature breakdown by ADA of 3'-DA and its HENT1 and kinase dependence. This has led to the selection of NUC-7738 as a clinical candidate, now in Phase 1-2 clinical evaluation for the treatment of advanced solid tumours or lymphomas. NUC-7738 was approximately 200-fold more active than 3'-DA, showing 3 to 56-fold higher intracellular concentrations. Moreover, HENT1, AK, and ADA inhibitors did not affect the intracellular 3'-DA TP levels generated by the protide. In order to generate the parent drug, the protide must be metabolized intracellularly to produce the free monophosphate form, catalyzed by a carboxyesterase type enzyme, which is responsible for the cleavage of the amino acid ester moiety. Then the active triphosphate will be generated after 2 consecutive phosphorylation reactions. Promising pharmacokinetic data from the ongoing Phase 1-2 trial have been already reported, showing that the protide NUC-7738 is resistant to ADA degradation and is capable of releasing active 3'-DAMP into cells, where it is rapidly converted to the active species 3'-DATP, overcoming the key cancer resistance mechanisms that limit the efficacy of 3'-DA.